Hello you all, my name is Shikha Dwivedi. I'm an expert in economics and I did my masters in the same. I have around 1.5 year working experience at MyAussieTutor. So today's topic for this presentation is autocorrelation. Okay, so first we start with the introduction. The autocorrelation occurs when the error term in one period is related to the error term in the previous period, and which can be denoted by this. The time series data follow a natural ordering over time. For example, if we are predicting the growth of stock dividends and overestimate and 1 year is likely to lead to overestimate in succeeding years. So it is likely that such data exhibit intercorrelation, especially if the time interval between successive observations in short, such as weeks, is short, such as weeks or days. Sometimes the term autocorrelation is used interchangeably. However, some authors prefer to distinguish between them. For example, Tintner defines autocorrelation as lag correlation of a given series within itself, lagged by a number of times units, while serial correlation is a lag correlation between two different series. So there are two types of autocorrelation, positive and the negative. Positive autocorrelation is when your p-value is greater than 0, or when positive errors tend to follow the positive errors and negative errors tend to follow the negative errors. And negative autocorrelation is when your p value is less than 0, and when positive errors tend to follow the negative error and the negative errors tend to follow the positive error. Okay, so what are the causes of autocorrelation? So this often occurs, first is inertia, which often occurs in macro time series data. For example, the US interest rate unexpectedly increases, and so there is an associated change in exchange rates with other countries as well. Next is the prolonged influences. So this is again a macro time series issue dealing with economic shocks, and it is not expected that the US interest rate will increase. Then the data smoothing or manipulation. So using functions to smooth data will bring autocorrelation into a disturbance terms. And the last is misspecification. So a regression will often show signs of autocorrelation when there are omitted variables, because the missing independent variable now exists in the disturbance term. So we get a disturbance term. Okay, so other causes may be like cobweb phenomenon, lags, non-stationarity. So, like in cobweb, in agriculture, suppose we take a agriculture market, the supply reacts to price with a lag of one time period, because supply decisions take time to implement. So this is known as the cobweb phenomenon. That at the beginning of this year's planting of crops, farmers are influenced by the price prevailing last year, right? And next is like lag. So one of the explanatory variable is the lagged value of the dependent variable in the auto regression equation. So if you neglect the lagged, the resulting error term will reflect a systematic pattern due to the influence of lagged consumption on current consumption. And the last, which is non-stationarity. So when dealing with time series data, one should check whether the given time series is stationary or not, because a time series is stationary if its characteristics, for example mean variance and covariance, are time variant, that is they do not change over time. If that is not the case, we have a non-stationary time series. Okay, so the positive correlation looks like this, which occurs when an error of a given sign tends to be followed by an error of the same sign. And the negative autocorrelation looks like this, which occurs when an error of given sign tends to be followed by an error of the opposite sign. Next are the issues and the consequences that are associated with the autocorrelation. So if we talk about the issue, which is the problem, so autocorrelation violates the time series assumption, which is T6, and T6 assumption states that the error terms must not be correlated across time periods. So the consequences that are associated with it are: under autocorrelation, parameter estimates are unbiased. Parameter estimates are not minimum variance among all unbiased estimators, and estimated standard errors are incorrect, and all measures of the precision based on the estimated standard errors are also incorrect. And how can we detect that there is an issue of autocorrelation in the data? So there are two ways in general. So first is the informal way, which is the graphical method, and the second includes the three major methods, which is test, basically the Durbin-Watson test, the Breusch-Godfrey test, and the run test. Okay, so in graphical method, the residuals are plotted against the time. This plot is called the time sequence plot. If time sequence plot doesn't exhibit any pattern, then autocorrelation is said to be absent. And if it exhibits some pattern, then autocorrelation is said to be present. Okay, so a run test is a statistical analysis that helps determine the randomness of data by revealing any variables that might affect the data patterns. Technical traders can use a run test to analyze statistical trends and help spot profitable trading opportunities. In this method, first the regression model is fitted using OLS method, and the residual are obtained, and the residual are arranged according to the time. Then the number of runs, which is R, formed by positive and the negative signs that are counted, and if it exceeds the tabulated value, then autocorrelation is said to be absent. So yes, these are the if n1 and n2 are number of positive and negative signs respectively, then for large sample the test can be approximated by the word test using these formulas, which are given below, which is of ER and the VR. Next is the Durbin-Watson test. So this test was developed by statistician Durbin and Watson, and it is used to test the null hypothesis that there is no autocorrelation. It is most frequently used test for the detection of the autocorrelation, and it is also called as Durbin-Watson D-test. So value near 0 shows the presence of positive autocorrelation, value near 4 shows the presence of negative autocorrelation, whereas value near 2 shows absence of autocorrelation. And yes, therefore a criteria was suggested by the Durbin and Watson can be constructed, and they construct a table for upper bound, which is du, and lower bound, which is dl, for the D statistic. This table is for 6 to 200 observation and a maximum of 20 explanatory variables. So basically the decision criteria is explained in figure on the next slide, which is here. So in this slide you can see that where you have to reject the null hypothesis, where you have to reject your alternate hypothesis, zone of indecision and zone of indecision. Do not reject null or this hypothesis or both. So these are the this is the test created by the Durbin-Watson. So some of the assumptions that are associated with this test is the regression model includes intercept term. The explanatory variables must be non-stochastic, non-random or fixed. The error term must be normally distributed. The regression term does not include any lagged past value of dependent variable. There must be no missing observations. Breusch-Godfrey test. So it is a test for autocorrelation in the errors in the regression model. It makes use of the residuals from the mode being considered in a regression analysis, and a test statistic is derived from these. The null hypothesis is that there is no serial correlation of any order up to P. Okay, so this is the end of the presentation. I hope you all liked it, and I'm looking forward for all of your queries and feedback regarding this. So thank you so much.